You wake up, check your phone, and instantly know it's 7:42. But imagine waking up thousands of years ago and having absolutely no idea what 7:42 even meant. No clocks, no watches, no alarms, no glowing numbers. And yet, people still had to know when to work, travel, plant crops, meet others, perform rituals, and sleep. So how did humans measure something they couldn't see, touch, or store? The strange answer is that they started by measuring things that could be seen: the sun, the moon, the stars, and eventually, even water. Because before humans built clocks, the entire world was basically one enormous clock face. And the first timekeepers weren't machines. They were observers. For most of early human history, you didn't need to know the exact hour. You needed to know whether it was morning, midday, evening, night, planting season, hunting season, or the time to move. That distinction matters, because we often imagine ancient people as having no real concept of time. They absolutely had one. They simply measured it differently. Start with the most obvious clock in human history: the sun. Every morning, it appeared. Every evening, it disappeared. And during the day, it moved across the sky in a predictable path. Humans could use that movement as a rough schedule. The position of the sun told you whether the day was beginning, reaching its middle, or heading toward darkness. But there was a problem. Looking at the sky gives you direction. It doesn't automatically give you a number. So humans turned to something much more useful: shadows. Put a stick upright in the ground. The sun creates a shadow. As the sun moves, the shadow moves. Now you've turned sunlight into a measuring instrument. This basic principle eventually became the sundial. Ancient Egyptians were using sundials and shadow clocks by the New Kingdom around 1500 BC. One Egyptian shadow clock could use a marked surface and a projecting piece called a gnomon to track the changing position of the shadow. Suddenly, time wasn't just something happening in the sky. It was something you could read from the ground. But there was another problem. What happens when the sun disappears? Your giant sky clock shuts down. So humans looked upward again. At night, the stars became the clock. Ancient Egyptians divided the night using groups of stars known as decans, tracking their movement across the sky. They weren't watching seconds tick by. They were watching patterns return. And that idea becomes even more powerful when you zoom out. Because humans didn't only need to know what part of the day it was. They needed to know what part of the year it was. And for that, the moon became enormously useful. The moon changes shape in a repeating cycle. New moon, crescent, full moon. Then it disappears and begins again. You don't need mathematics to notice that. You just need to pay attention. Ancient calendars developed around these recurring cycles. In Egypt, calendars were organized around lunar patterns and agricultural seasons, while the year was divided into 3 major seasons linked to the Nile: inundation, emergence, and harvest. Now time becomes something much bigger than what hour is it. It becomes prediction. When will the river rise? When should crops be planted? When will a particular star appear? When should a community prepare for what comes next? And this is the first big twist. Ancient humans weren't necessarily obsessed with precision. They were obsessed with patterns. Today, being 5 minutes late can feel like a personal crisis. For many ancient activities, after sunrise, when the shadow reaches here, or when the season changes, could be perfectly useful. But eventually, some situations demanded something more precise, especially when the sun wasn't available. Enter the water clock. Instead of waiting for the sky to move, humans made water move. The basic idea was beautifully simple. Put water in a container. Let it drain through a controlled opening. Mark how much water has passed. Now the flow itself becomes a timer. Ancient Egyptian water clocks are known from later periods, including examples dating to the Late Period and Ptolemaic period. One surviving Egyptian example, dated to 664 to 30 BC, is decorated with baboons and is considered a model of a water clock. Water could drain through an opening over a measured period. Think about what just happened. Humans took something that naturally flows, controlled it, and turned that flow into a measurement. That's a huge conceptual leap. Because now you don't need the sun. You don't need stars. You don't even need daylight. You just need gravity, a container, and a predictable flow of water. But even this wasn't perfect. Water doesn't always flow at exactly the same rate. The shape of the container matters. The water level changes. Temperature can matter too. So timekeeping became an engineering problem, and humans kept solving it. Meanwhile, the calendar problem was getting even more complicated. A day is not exactly the same thing as a month. A month doesn't fit perfectly into a year. And a year isn't exactly 365 whole days. The ancient Egyptians eventually used a civil calendar of 12 months, each with 30 days, followed by 5 additional days at the end of the year. That's 365 days. But the astronomical year is about 365.25 days. So their calendar gradually drifted against the seasons. And this reveals something important. Measuring time isn't just about building a better clock. It's about deciding what kind of time you're trying to measure. Hours? Days? Months? Seasons? Years? These aren't interchangeable. Modern humans solve the problem by stacking them into a standardized system. Seconds, minutes, hours, days, weeks, months, years. Ancient humans often started from the opposite direction. They noticed the cycles first. Then they created ways to describe them. Then they built tools to measure them. And eventually, humans created systems where time could be detached from the sky altogether. That was the real revolution. A sundial still depends on sunlight. A lunar calendar depends on the moon. A seasonal calendar depends on Earth's repeating environmental cycles. A water clock depends on physical processes. Each step makes time more portable, more controllable, more abstract, and that eventually leads toward mechanical clocks. But here's the contrarian part. The invention of clocks didn't create humanity's relationship with time. It changed the precision of that relationship. Humans had been tracking time for thousands of years before a clock could tell them it was exactly 7:42. They just didn't always need the number. They needed the pattern. The shadow moved. The moon changed. The stars returned. The river rose. The seasons turned. And humans learned to notice. Today, your phone tells you when to wake up. Your calendar tells you when to leave. Your watch tells you how late you are. And your microwave can tell you exactly how many seconds remain until your food is ready. Ancient humans had none of that. Yet they still built lives around time. They simply read it from the world instead of a screen. And maybe that's the strangest part. We didn't invent timekeeping because humans suddenly discovered time. We invented it because humans became very good at noticing that the world keeps repeating itself. The sun returns. The moon returns. The seasons return. And, eventually, humans built something that could make those invisible cycles into numbers. That is how time became something you could carry in your pocket. If you enjoyed this video, subscribe for similar ones and feel free to drop suggestions for the next video in the comments.